The next section we're going to get into is scientific notation. Scientific notation actually makes life easier for writing numbers out, as long as you understand the rules for what they are describing. If you don't like putting a bunch of zeros for a very large or very small number, this is the system you use, and this is the system I use most of the time. All right? And the basic idea of this is that you have a number between 1 and 10 times a power of 10. And what I mean by that is, this is an example of scientific notation. .25 times 10 to the 7th. Now, this number here has to be somewhere between 1 and 10. It can include 1, but it cannot include 10. And if you were to punch this out in your calculator, you might get something similar to this, or they might be the actual number, which is this. And I really hate writing zeros, and I really don't like it when people write numbers in zeros and don't put the commas in. And you notice that every 3 numbers in front of the imaginary decimal point here, you have commas. And we do this generally anytime you have more than 4 digits. If you have 4 digits like 5,328, there's no need for a comma because it's very easily seen. But once you get past that, it starts to get a little cloudy. And the rules generally is once you get past 4 digits, you need to start putting commas in. Okay? So, take, for example, we talked about this in the previous session, an astronomical unit. An astronomical unit is defined as 93 million miles from the Earth to the Sun. Now that's an average. It actually doesn't travel in a circular path around the Sun. It's what we call an elliptical path. And this is the average. We talked about this, like I said before. Again, if we want to avoid writing all these numbers, the best thing to do is to identify where the decimal point is, and that's right there. And then move that decimal point over between the first 2 numbers so that you end up with a number between 1 and 10. So if I do that, move it in this direction right here, I end up with 9.3. Now all these zeros are placeholders. They're not significant. The 3 is the doubtful digit, so that means we have 2 significant figures. And we must represent the same number of significant figures in the scientific notation. So if this has 2, this has to have 2. Times 10 to some power. Well, since this is a large number, we know that this is going to be a positive exponent. And when I say large number, it's going to be greater than 1. All right? So, we count the number of decimal places we have to move the decimal point, and it's 7. So we put a 7 right there. And that is, with the label miles, the scientific notation representation of an astronomical unit. So, when we talk about powers of 10, if you have a positive power of 10, you're dealing with a large number. And, the same can be true for decimals, only now these are extremely small numbers. But again, we have a bunch of zeros in as placeholders. And if you recall from the rules of significant figures, that a zero is significant in 2 places. One, if the zeros are between 2 non-zero numbers, which we don't have here, or the zeros at the end of a decimal. And the reason why that's significant, again, is because it didn't have to be there. The fact that it's there means that it is measured to that doubtful digit place, and therefore has to be significant. And therefore we have 2 significant figures here. So whatever we do with that, we have to end up with 2 significant figures. So, I think that's what we got here. Yeah, that's what we had. Okay, so we do the same thing we did with the 93 million. We take the decimal point right here, and we move it. Now we're going to, instead of going to the left, we're going to move it to the right, so that we end up with a number between 1 and 10. So if I move it right there, that gives me 5.0. And this has two significant figures, and this has two significant figures, because these are both zeros at the end of a decimal, which means we have rounded off to those places. Then we put times 10, and then we count the number of places it went past to get to between 5 and 0. And we count those places, it's 5. But because this is an extremely small number, the exponent has to be shown as being negative. So this is a negative 5. And the label here is minus. So, if it's big, it's going to have a positive exponent. If it's small, it's going to have a negative exponent. Keep that in mind. And the number of significant figures must be the same for both before we got the notation and after we have the notation. Okay? Now, when we calculate numbers with scientific notation, we generally leave the answer in scientific notation. If you have numbers that are not in scientific notation, you may or may not use scientific notation. I generally do, just because I don't like writing all those numbers and all those zeros particularly. Example here that I use is rewrite this into scientific notation. Well, again, how many significant figures do we have here? 3. 7, 4, and 0. That 0 can have to be there. These zeros have to be there, therefore they are significant. I'll move this decimal point over 6 places. And because this is less than 1, it's going to have a negative exponent. So that means that this is going to be 7.40 times 10 to the negative 6. And I guess the label for that was seconds. Now, in working with calculations involving scientific notation, it's no different than working with any number, in that we have to adhere to the rules of significant figures. This number here has 3 sig figs. We don't look at this for significant figures. This is the only number we looked at. It has 3 sig figs. When we take this whole number to the third power on our calculator, we have to end up with 3 significant figures. Now, when you work this problem out, we have 7.65 times 10 to the 5th quantity cubed. And what's the label? I'm forgetting the stinking label. Label, kilometers. All right, kilometers. So we should have kilometers written here. I have to cube this number. So when you go to your calculator, you can do it exactly the way it's written here. You put 7.65 times 10 caret 5 closed quantity to the third power. Or you can use a shortcut form they use, and I'm going to caution you on that in just a little bit. It actually makes it quicker to be done. It's 7.65. Take a look at your calculator, your graphing calculator, your scientific calculator, and you notice that there's a comma button on the left-hand side of the calculator. Right above the comma, you'll see on the board of the calculator an EE key, capital E key. If you hit second function and then that comma key, instead of giving 2 EEs like it says on the board, it's actually going to give you 1. And the reason why they do that is because they don't want people to get confused with another E that's on the calculator. If you take a look on the left-hand side of the calculator, there's an LN key. LN stands for natural logarithm. It's French, that's why they have the letters turned around. When you take a look above it, you'll see a lowercase e, and that's called the natural number or Euler's number, which we're not going to use in this class. But in order to keep any confusion from that, they use the double capital E to emphasize that that's not Euler's number for those people who care about that. You don't, so don't worry about it. But that's why they do that. Now, that E key is the time sign, a 10 number, and then a caret, all bunched into one. It's just telling the calculator that that represents 4 pieces of information. Times 1, 0, caret, 4 pieces. So it saves space on the memory of the calculator / mini computer. The exponent that we're looking for is 5, so you just hit 5 after the E key. And then in your calculator, the upper left-hand portion, you have a key that says math. Hit that button and you will see a pop-up of several functions. If you notice at number 3, it has a tiny exponent of 3 written there. So you can either just scroll down to that, hit enter, or just hit the number 3 on your calculator, and it'll pop up a 3 right here. You don't have to put parentheses in for this. And the reason why is because this has been programmed to understand this is one number taken to the 3rd power. If you put a parenthesis around it, that's fine, better safe than sorry, I have no issue with that. The whole point of this is doing it as quickly as possible. Like when we get a whole bunch of problems, we're trying to solve them quickly, it kind of gets laborious to keep using all those parentheses and times and pens and carets and oh my goodness. And when we start dividing with them, then it really is an issue using the parentheses, and we tend to stay away from the parentheses. So use this process whenever possible. Punch that out in the calculator, and you get 1.08 times 10 to the 17th cubic kilometer. times 10 to the 17th when you round it off to 3 sig figs. That's 3 sig figs right there. And then because the kilometers is in here being cubed as well, and that means you're going to end up with cubic kilometers as your label. So we're probably looking at some celestial body out there in space that has these dimensions. So, that leads us to our practice problems. We have 6 of them. 4 of changing the scientific notation, 2 of changing the scientific notation into regular numbers. Good luck.